Let me start today with a scenario that I think a lot of us have experienced. Have you ever felt a tiny twinge of guilt after yelling at your voice assistant because it misunderstood your command? Or maybe you've seen those videos of engineers kicking robotic dogs to test their balance, and you felt this visceral sense of discomfort. It raises a really fascinating question. Are we just projecting our human emotions onto these machines, or are we actually moving toward a future where intelligent machines might deserve moral consideration, where we might actually owe it to them to treat them well?
It is a question that is keeping a lot of technologists and philosophers awake at night right now. We see artificial intelligence taking on roles as caregivers, companions, and autonomous decision makers, and it naturally makes us wonder if we need to expand our moral circle. But today, we are going to dive into a rigorously argued paper by philosopher Parisa Moosavi, published in Philosophy and Phenomenological Research in 2024. The paper is titled, "Will Intelligent Machines Become Moral Patients?" And Moosavi takes a stance that pushes back against a lot of the current hype. Her argument is that, despite how advanced machine learning is getting, we actually have absolutely no good reason to believe that AI will ever become a moral patient.
And just to clarify for our listeners, when we use the term moral patient in philosophy, we aren't talking about a machine going to the hospital. We are talking about an entity that can be morally wronged, an entity that is owed moral protection in its own right. To really unpack Moosavi's argument, we need to understand what it actually takes to be a moral patient. She uses a framework developed by Kamm, right? Can you break down Kamm's criteria for us?
Absolutely. Kamm's framework is brilliant because it draws some very necessary boundaries. According to Kamm, for an entity to be a moral patient, it must count morally in its own right and for its own sake. Let's break that down with 3 examples from the text. First, think of an ordinary rock. A rock does not count morally. You can smash it, skip it across a lake, it doesn't matter. But if that rock is a crucial piece of evidence in a murder trial, it suddenly becomes morally impermissible to tamper with it. However, it only counts morally in an instrumental way. You aren't protecting the rock for the rock's sake. You are protecting the justice system for the sake of humans.
Okay, so instrumental value doesn't make you a moral patient. What about something incredibly valuable, like the Mona Lisa? We definitely believe it is morally wrong to destroy the Mona Lisa. We value it as an end in itself, not just as a tool. Does that make the painting a moral patient?
No, it doesn't. And this is where Kamm's second distinction kicks in. We value the Mona Lisa non-instrumentally, but we do not preserve it for the sake of the painting itself. It's not like preserving the Mona Lisa is somehow good for the canvas and the paint. As philosopher Korsgaard puts it, the value is still tethered to us. We are the ultimate beneficiaries of its aesthetic value. A human being, on the other hand, is entirely different. If you save a human from drowning, you are doing it for their sake. They get something out of being saved that a painting does not. So bringing this back to Kamm's framework, to be a moral patient, an entity must have what we call a good of its own. It must be capable of being benefited or harmed in a way that matters to the entity itself.
That makes perfect sense. So the entire debate hinges on this one question. Can an artificial intelligence ever have a good of its own? And this is where Moosavi's logic chain really starts to build. If moral patiency requires having a good of your own, how do we determine if a machine can have that?
Moosavi argues that having a good of your own requires something called non-derivative teleology. Teleology just means having a purpose or an end goal. But the non-derivative part is the key. You see, traditional human-made artifacts, like a knife or a thermometer, definitely have a purpose. A knife's purpose is to cut, but that purpose is derived entirely from human intentions. The knife doesn't care about cutting. We care about the cutting. Therefore, its teleology, its purpose, is entirely derivative. Because its purpose is derived from us, a traditional artifact cannot have a good of its own.
I can hear people pushing back on that already. People might say, sure, a knife is just a dumb tool. But what about a highly advanced AI? To say an AI's purpose is derived from humans just because humans built it sounds a bit like saying a child's purpose is derived from their parents just because the parents made the child. How does Moosavi respond to that?
That is exactly where Moosavi introduces a crucial philosophical distinction, and it's one of the most important concepts in her paper. She distinguishes between causal dependence and constitutive dependence. When parents have a child, the child's existence is causally dependent on the parents. The parents initiated the causal chain that led to the child. But once the child exists, their nature as a biological being gives them their own internal teleology. Their goals and their well-being are constituted independently of the parents' intentions. But for an artifact, its dependence on human intention isn't just causal, it is constitutive.
Constitutive dependence. That means the human intention doesn't just cause the object to exist. It literally defines what the object is.
Exactly. A thermometer isn't just a tube of glass with mercury in it that happens to expand. It is constituted as a measuring device by our intention to use it to measure temperature. Without human intention, it's just glass and metal. Its very essence as an artifact is constituted by the purpose we assign to it, and because its teleology is constitutively dependent on us, it cannot possess a non-derivative teleology. It cannot have a good of its own.
Okay, I follow the logic perfectly for traditional artifacts, but we are living in the age of machine learning. AI systems today are not explicitly programmed with rigid rules like traditional software. We give them a massive dataset, and they learn, adapt, and develop their own novel strategies to solve problems. Sometimes they do things that completely baffle their own creators. Doesn't this self-learning capability, this autonomy, break that constitutive dependence? Aren't they generating their own purposes?
That is the most common counter-argument, and Moosavi tackles it head-on in section 7 of her paper. She argues that machine learning only reduces the causal dependence on humans, but it does absolutely nothing to touch the constitutive dependence. To illustrate this, we have to talk about Nick Bostrom's famous thought experiment, the paperclip maximizer.
Oh, the paperclip maximizer. That's the classic existential risk scenario, right? Where an AI is given the seemingly harmless goal of manufacturing as many paperclips as possible, and it ends up destroying the entire universe to harvest atoms to make more paperclips.
That's the one. Bostrom uses it to show how AI can become incredibly dangerous even with mundane goals, but Moosavi uses it to make a point about teleology. Think about the paperclip maximizer. Through machine learning, it might develop highly complex, autonomous sub-goals. It might learn how to manipulate financial markets to buy aluminum, or learn how to neutralize human threats that try to turn it off. It might invent entirely new scientific paradigms. It has a massive amount of autonomy in how it operates. The causal chain between what the programmer coded and what the AI is doing is incredibly long and opaque.
But, fundamentally, it's still just making paperclips. All of those complex, terrifyingly smart sub-goals are entirely in service of the ultimate objective that was handed to it by a human.
Spot on. The AI has learned new instrumental goals, but its ultimate teleology remains entirely derivative. It is still constitutively dependent on the original human intention. Maximize paperclips. No matter how many layers of neural networks you add, or how much reinforcement learning it undergoes, machine learning is just a mechanism for optimizing the path toward an externally provided goal. It doesn't magically generate a non-derivative purpose out of thin air. Therefore, according to Moosavi's logic chain, machine learning does not move AI a single step closer to having a good of its own.
So, if I can summarize the argument so far, to be a moral patient, you need a good of your own. To have a good of your own, you need non-derivative teleology. Artifacts have a teleology that is constitutively dependent on human intention, which means it is derivative. Machine learning only alters how goals are achieved, not where they come from. Therefore, AI cannot have a good of its own. It's a very tight logical loop. But what if we approach this from a completely different angle? What if we ignore the internal wiring and the origins of the AI and just look at the results? Because if I see a sophisticated humanoid robot crying out in pain, begging me not to shut it off, it's going to feel incredibly wrong to pull the plug. This brings us to John Danaher's concept of ethical behaviorism, doesn't it?
Yes, and this is a massive debate right now. John Danaher argues for ethical behaviorism, which essentially states that if an AI behaves in a way that is functionally equivalent to an entity that has moral status, we should grant it the same moral status. The idea is that behavior is the only reliable evidence we have for moral status anyway. Danaher points out that we can't actually look inside the minds of other human beings to see their consciousness or their inner teleology. We only infer that other humans are moral patients based on their behavior. So, if an AI exhibits the exact same outward behaviors expressing preferences, avoiding damage, displaying social reciprocity, it is philosophically inconsistent to deny them moral status just because they are made of silicon instead of carbon.
It's basically the Turing test applied to ethics. If I can't tell the difference between a human suffering and an AI suffering based on their behavior, I have to treat them both as moral patients. It sounds quite pragmatic. How does Moosavi counter Danaher's ethical behaviorism? Because it feels like a very strong epistemological point.
Moosavi's counterargument here is deeply fascinating. She argues that Danaher fundamentally misunderstands the epistemological basis of how we attribute minds and moral status to other human beings. It's not just about observing outward behavior in a vacuum. Moosavi points out that our knowledge of other human minds relies heavily on first personal self-knowledge.
First, personal self-knowledge. Meaning, I know what it feels like from the inside to be me. I know I have a mind, I know I feel pain, and I know I have a good of my own.
Exactly, you have direct access to your own inner life. But how do you extend that to me? You don't just look at my behavior. You look at my behavior in conjunction with the fact that we share a biological and evolutionary constitution, you know that I am a human being, built from the same evolutionary blueprint as you, with a similar nervous system. So, when I scream after stubbing my toe, you use your first personal self-knowledge, combined with our shared biological reality, to reliably infer that I am experiencing the same inner state of pain that you would. The behavior is just a symptom of a shared underlying constitution.
Ah, I see the trap for AI here. We don't share any biological or evolutionary constitution with a machine, so that bridge of inference completely collapses. When the AI screams or begs not to be shut off, we can't use our own first personal experience to assume there is any inner life there, because the underlying hardware and the origin story are entirely different.
Precisely. And Moosavi adds another devastating point against ethical behaviorism. We know that AI systems are explicitly designed and programmed by humans to mimic human behavior. If a parrot says, "I have a headache," you don't offer it an aspirin. You know, the parrot is just mimicking sounds it heard from humans. In the same way, when an AI mimics the behavior of a moral patient, the most rational explanation is not that it has magically acquired a non-derivative inner life. The rational explanation is that it is simply doing what it was designed to do: replicate human behavior. Behavioral similarity in an artifact that was built to be similar implies replication, not a shared underlying capacity. Therefore, behaviorism is not a sufficient standard for granting moral status to machines.
That is a remarkably robust defense against the behaviorist view. It strips away the illusion created by advanced mimicry. But I want to make sure we accurately represent the strength of Moosavi's conclusion here. She is a philosopher, so she is being very precise with her wording. She isn't claiming that it is a fundamental law of physics that AI can never, ever have moral status, is she?
That's a great observation, and it's vital to her academic fairness. Moosavi maintains a stance of epistemic modesty. Her conclusion is not, "We know with absolute certainty that AI lacks moral status." Instead, she carefully concludes that we have no good reason to believe that AI will become moral patients. She explicitly concedes a few things. For instance, she admits that it's not logically impossible for an artificial entity to somehow acquire moral patiency. She even makes a concession regarding consciousness, acknowledging that while phenomenal consciousness might not be strictly necessary for moral patiency, even if it were, AI wouldn't meet the mark based on her teleological arguments. She is basically saying, look at the evidence, look at the mechanisms of machine learning, look at the nature of artifacts. None of these things point toward an AI developing a good of its own.
So all the panic, all the think pieces about whether we are enslaving conscious algorithms are essentially jumping at shadows, at least according to this framework. We are letting the sophisticated mimicry of language models and robots trick our evolutionary instincts.
Exactly. We are naturally empathetic creatures. When we see something that talks like us and acts like us, our moral radar pings. But Moosavi is urging us to use philosophical rigor to override that instinct. The nature of intelligent machines does not make them a better candidate for acquiring moral patiency than the traditional artifacts whose moral status doesn't concern us at all. We don't worry about the moral rights of a hammer. And fundamentally, despite the massive increase in complexity, machine learning hasn't changed the fact that AI is closer to a hammer than it is to a human being.
That is an incredibly grounding perspective. In a world where technology is moving so fast that it feels like magic, it's reassuring to have a philosophical anchor that reminds us what actually constitutes moral value. It comes down to having a good of your own, born of a non-derivative purpose, deeply rooted in our shared reality. It really shifts the focus back to us, the creators, and how we choose to use these highly capable, but ultimately non-moral tools. This has been a deeply enriching breakdown of Parisa Moosavi's work. Thank you all for joining us on this deep dive, and we will catch you in the next discussion.